This is the Algebra 1A semester exam review, and this will be the section on Chapter 2, Variation. I'll probably do this in a couple of different videos just so it's not as long, not as difficult to upload. So this first video will cover probably this first page, maybe front and back. So, okay, starting out with number 1. On the graph of y equals k over x, and really what this is looking for is a limit. That's what this is called. As x approaches negative infinity, what happens to your y values? Well, in order to answer this question, we want to know, we're going to have to know what the graph looks like. Okay, and the graph stuff will come up again later on, but this graph in particular is going to be a hyperbola in the first and the third quadrant. Okay, so it looks something like that. And if you remember how this graph works, these lines right here are what's called asymptotes, meaning that the graph approaches them, but they get really, really close to those lines, but they never actually touch them. So what this question is saying is, as x approaches negative infinity, which is here, right? Negative infinity would be like if I walk out along this line forever and ever and ever and ever. What's happening to the y values on my graph? So as you walk out in this direction, we're looking at kind of this branch of the graph, it's going to get closer and closer and closer to that line, and that line's y value is 0. Okay? So as you walk out forever and ever to the left, okay, so this right here, negative infinity means walking out to the left, what's happening to your graph? It's getting closer and closer to 0 on the y-axis. Okay, number 2. Suppose z varies inversely as the square of y. And I've had a lot of questions on how to set that up. It's very literal. It's very word for word. So z varies inversely, so that means I'm going to be using division, with the square of y. So this is what's called my general formula. Okay? Now I need to solve for my k value, so I'm going to do that by plugging in my y and my z value. So I'm going to say 14 equals k over 3 squared, which is really 14 equals k over 9, which means I would multiply by 9 on both sides, and let's see, that's going to be, so 126. So I start with a general equation, I find my k value, and now I'm going to go back to my general equation, plug in my k value, and I'm going to plug in this y equals 18. So I'm going to say z equals 126 over 18 squared. And this number does come out kind of strange. I don't remember what it is, but 6 divided by 18 squared comes out to be 0.38 repeating. And I know that number seems kind of weird, but that is the correct answer. Okay, 0.38 repeating. Okay, so number 3, kind of the same thing, except this time we're doing direct variation. So y varies directly, meaning y equals k times something as the cube of x. Okay, so start with my general setup. That comes straight from this variation sentence. Now I'm going to plug in the 250 and the 2.5. So y is 250. K times 2.5 cubed. So this is really saying 250 equals, let's see, 2.5 to the power of 3. Is 15.625. And then I'm going to divide by that 15.265, or sorry, 625. And I get 16 for my k value. Okay? So I found my k value of 16. Now I'm going to go back to my general equation. And I'm going to say y equals, now I know that k is 16 times my x value cubed. I guess I should put my calculator in here so you can see what I'm doing there. So I would do 16 times 1.5 to the power of 3, and I end up with 54. Is my final answer there. Okay, this next part, this table, is really just seeing if you remember what all of these graphs look like. So these two are direct variation, these two are inverse variation. That would be a good kind of distinction to know. So these are direct, these are inverse. Okay. Direct variation is always just going to be a line. That's a linear function, always going to go through the origin. Direct square variation, anytime you work with an x squared, and you should know this because we just covered this in chapter 6 as well, anytime you have an x squared in there, you're going to get a parabola. Okay. We talked about this graph up above in number 1, inverse variation. That's going to look like a hyperbola here and here. And then this one is also going to look like a hyperbola, except when you square that x, it takes all of these negative values and flips them into the positive territory. So this hyperbola is going to be in quadrants 1 and 2 instead of quadrants 1 and 3. Okay? So I would make sure you're just familiar with those general shapes of all of those graphs. Now, I didn't say too much about this, but k greater than 0 is really saying when k is positive. So this is like when k is a positive value. That next line wants to know what happens to these graphs when I make k negative. Okay? And the effect on all of the graphs is exactly the same. Making k negative takes your graph and flips it over. It's a vertical flip. It's a flip over the x-axis. So it flips down here. This one's going to flip both of these, and this one's going to flip over. So this one would end up looking like this. So it's still a linear function, still goes through 0, 0, but just points the other way. This is going to be a parabola pointing downward, which really, if you think about it in terms of the stuff we're doing more recently, the k value is really like your a value when you're looking at a quadratic equation. And we've already learned that when a is negative, your graph flips over. This would be a hyperbola in the opposite quadrant. So this is going to go here and here. And then this one, instead of both being on top, they would both be on the bottom. So again, just I don't think there's anywhere on your exam where it looks like this, where there's a table and you have to draw all of them. But to answer the questions, you're going to really need to make sure that you're familiar with all of those shapes. So that'd be a great thing to study if you feel like you're struggling with those. Okay, number 5. Oh, a lot of questions on this one too. So first of all, it says create a scatter plot of this data. Let's just review how to get a scatter plot in here. On your calculator, you're going to go to the Stat button, which is here next to the arrows, Edit, and then List 1, List 2, that's where you're going to type your data. Now, if you already have other data in there, you can go up to the top of the list where it says L1 and hit Clear and Enter. L2, Clear, and Enter. Okay, that's how you clear your list out so that you can type in your new data. And I also in class, sorry I didn't make this change on mine, I changed this to a 5 instead of a 4. So I'm going to type this first set of numbers into list 1. So 3, 5, 6, 8, 9. And then list 2 is going to be these numbers. Okay, once you have your data in the list, if you want to see a picture of it, I would go to your y equals, and you need to tell your calculator that you're not looking for an equation here. You're not graphing an equation. Instead, you're graphing the data from your lists. So you want to go up to this plot 1 and turn it on. And that's how you tell your calculator to look at the stat lists instead of looking at for an equation. And then you also want to tell your calculator to adjust your graph to fit the data. So you would hit zoom, and I think it's number 9. Yep, number 9, zoom stat. Okay? And that's what my data looks like. And you can kind of see, I mean, it might be a little bit hard to see the curve there, but there is sort of that hyperbola look to it, okay? So if it's a hyperbola of some kind, we know for sure it's going to be inverse variation, okay? And as far as how we know, we could either say we know from the graph, or if you notice from the table, as L is increasing, as number is getting bigger, these numbers are getting smaller. Okay, and remember when you have that up and down relationship, that's always going to be inverse variation as well. So we could know this by looking at the graph or looking at the data when L increases, F decreases. I'm sure someone will be able to make sense of that one day. Okay, the problem is now, both of these graphs look the same in the first quadrant, okay? We don't know if this is a hyperbola where the other part is down here in the third quadrant, or if it's a hyperbola where the other part is over here in the second quadrant, because there is no other part, okay? So here's what we have to do. We have to pick one of these, okay? We have to work through it as though it were the right answer. We have to find our k value, and then we have to test it with another data point to make sure that it works. So if I start with this one, I'm going to start with this equation here. What I would do is I would pick a data point to plug in for F and for L. So let's just go with, I don't know, 8 and 45. Okay, so I'm going to plug in 45 for force, and 8 for length, and then I'm going to solve for my k value. So I would multiply by 8 on both sides, and I get that k is equal to 360. Okay, if that were true, if I used the right equation, this k value should work for every other data point in the table, which means my equation would look like this. Okay, F equals 360 divided by L. I want to make sure that that's true for these other data points. I don't have to test all of them. Probably just even having one other one where that works would be enough to convince me that I'm right. But let's try it with like the 3 and the 120. So what I really want to know is, does 360 divided by L, or divided by 3, give me 120? And I know that it does, but so I would test that. Oh, it did come out to be 120. Okay, so this equation does work. Okay, so in terms of answering this question, this is my equation. F equals K over L. Worked correctly for me because this equation held out to be true in this data point, and actually if you checked any of the other ones, it would work for those as well. Okay. Now, down here it says write a specific formula including the k value to represent this situation. We kind of already did that. Okay, we did that right here. We had to do that to be able to test it. By the way, I meant to say that on this one. If this had not worked, if we had done this and it didn't hold true for these other data points, I would have had to repeat this whole process with this other equation. That's why I kind of set it up in like 2 pieces here, but I didn't end up needing to do that second one because the first one worked for me. Okay? So my specific formula would just be F equals 360 divided by L. And then it says how many pounds of force would be required to turn a 12-inch wrench. Well, this is your L value, right? So I would say F equals 360 divided by 12, which should give you 30 pounds of force. Okay? Okay. On to number 6. So number 6 is giving us a table. Oh, sorry. Didn't realize you couldn't see that one. Number 6 is giving us a table again, talking about the weight of a man, a 200-pound man, at various distances from the center of the earth. Oh, excuse me. And I want to know how much would he weigh if we went 4,005 miles up from the Earth's center. Okay. This problem is actually exactly the same as number 5, except instead of stepping you through this piece by piece like A, B, C, D, I just ask you to go straight from data table to a question like question D. But you're still going to have to kind of follow through all of these steps, okay? So I know just from looking at this data, and maybe that's an easier way to go if you don't want to do the scatter plot every time, because the scatter plot really just helps you with the shape of the graph. I know from the data that this is inverse variation. And again, because my top row is increasing, my numbers are getting bigger, and my bottom numbers are decreasing. So when you've got that opposite relationship, this is telling me I have inverse variation. Okay? So again, I know it's either going to be W equals K over D, or W equals K over D squared. It's going to be one of these two. Okay? I don't know which one. So let's suppose it's this one. I'm going to plug in a data point. I'll just use this one. So I'm going to say 200 equals K divided by 4,000. Okay? To solve for my K value, I'd multiply by 4,000 on each side. Just want to make sure I don't screw up my zeros here. And I get a K value of 800,000. That means that I should be able to do 800,000 divided by D and get W for all of these other data points. Okay, so that's what I'm going to do. I'm going to take 800,000 and divide by 158. And it should give me 4,500. Oh, that does not look like 4,500. And you may in your brain be thinking, but gosh, isn't that close enough? I don't know, let's try another one. So let's try 5,500. So 800,000 divided by 106 should give me, oh, I'm sorry, I did that backwards, didn't I? I did. I apologize. It's 800,000 divided by the distance. So back up. So 800,000 divided by 4,500 should give me 158. It's still not going to work out, but 800,000 divided by the distance of 4,500 should give me my weight. Nope, didn't work out, okay, because this is 177, that's 158. If I jump down here to one of these and I do 800,000 divided by 5,500, it should give me 106, and it gives me 145. I would say that's probably too far off, okay? So now what I'm going to do is I'm going to run through that same process, except I'm going to use the D squared and see if that makes a difference. That is going to change my K value, though. I can't just keep the same K value. So let's use these same points, the 200 and the 4,000. So I'm going to say 200 here equals K, except this time that 4,000 is being squared. So when I go to find my K value, I'm going to do 4,000 squared times 200. That's going to be gigantic. And I get a K value of, oh gosh, I don't even know how many zeros that is. K equals 2, 3, 5, 6, 7, 3,200,000,000. Okay? Which again means that my equation would now read that number, 3,200,000,000 divided by D squared. Let's see if that works out better. So I'm going to take that number and I'm going to divide by 4,500 squared, because I want to divide by D squared. Okay? And I get 158 with a decimal. Okay, so it's not exact, but gosh, that's pretty close, right? Okay, let's check it in another one just to make sure. So 200 million. Hopefully I got the right number of zeros there. And let's divide it by 5,500 squared. Okay, and I get 105.7, which is awfully, awfully close to 106. So that's one where I would say that that's close enough. Okay, so we know now that this equation is the correct one. Okay, and we can just cross this off. Okay, so you do have to test both. If you think you have an instinct about it and you think you could have guessed this one from the beginning, that's great, but I would still go through and test it first. If you had wanted to start with this one, that would have been fine. And that still doesn't answer our question. Our question is, I'm going to squeeze this in at the end. I don't think I thought about how much space this one would take when I put it on the paper here. How much would he weigh if he was 4,005 miles from the surface? Which really, when he's 4,000 miles from the surface, this is how much he weighs. So 4,005 is going to be just a little bit past this, which means it's going to be a little bit less than 200. So we have an idea of whether our answer is right or not. But to solve that, we would go, oh, I should really write this in scientific notation or something. Big crazy number divided by 4,005 squared. Okay, 3,200,000,000 divided by 4,005 squared. And I get 199.5. So climbing to the top of Mount Everest, you'll lose half a pound. Well, you'll probably lose more than that just in the exercise. But if you were magically teleported to the top of Mount Everest, you would drop about half a pound here is what you're seeing. Okay? So that one did take a little more space than I was expecting, but that's kind of the process you would have to work through, and that's what I mean when I say to test it, is you have to find it, test it. If it doesn't work, try the other one. Okay, it really is trial and error here. Okay, that's going to do it for this video. I will pick up with a new video starting with the next page.